In question 35, we've got an object which is initially at the origin with a velocity of 1 meter per second. So I'm going to jot down that as a clue in algebra. When t equals 0, x equals 0 because we're at the origin, and v equals 1. So that's a clue I can use later on. Now it's moving in a straight line and I know the acceleration function. So think about what you know about motion. You have formulas for displacement, velocity, and acceleration. To get from one down to the next, you need to differentiate, but to get from the lower ones, like acceleration and velocity, back up, you need to integrate. So to get a formula for velocity, we need to integrate the acceleration. Now, why would we want to do that? Well, because we're looking to find the time as an exact value when the particle is stationary. Now, stationary means that you're stopped, and that means you have no speed, no velocity at all. So we want to solve v equal to 0 and see when that happened. So we need a formula for v to start off with. Now, integrating an exponential function where you've got e raised to a power, if you have it in the form e raised to some function of x and you've got f dash x out the front, that's the most ideal thing to integrate because the answer is really, really simple. You just get e to that function plus c. Now, ideally then, if our function is minus t squared, what we would really prefer in an ideal world is if we had the differentiation of that out the front. Now, differentiating this part gives me minus 2t. So that's what I wish was there. Instead, I've got minus 4t. That's okay, we can adjust for it. So write the question that you wish you were given. That's my method, like that. And then say, well, hang on a minute, I've changed it. I need to adjust for that. And this is my adjustment factor that comes out the front. Now, this part is really easy to integrate because it follows that formula that's on my formula sheet. So the 2 comes along for the ride. And then when I integrate this part, I just get e to the power of minus t squared plus c. So that's the first version of my velocity formula. It's not yet finished though because I need to work out what the constant is. So I've got my clue now, which I've already put into algebra to make it simple. I know that when v equals 1, then t equals 0. So I can sub in this. Now, e to the power of 0 is 1. So what I'm saying is 1 is equal to 2 plus something. That something must be minus 1. So now I can rewrite my formula for velocity, and instead of having that c sitting on the end, I can write it more fully with that minus 1 where it should be. All right, continuing on now, I need to solve this by letting v equal 0 and finding a value for t to see when that happens. So let's rewrite our formula for velocity now. We want to let v equal 0. So 0 is equal to 2e to the minus t squared minus 1. Adding 1 to both sides, I get this. Halving both sides, I get that. Now, this is why this is quite a tricky question. When you get to here, a lot of people get stuck. And the reason you might get stuck is because if you rewrite this right now as a log, then you're likely to go, all right, I've got e to the power of minus t squared is equal to a half. And if you then want to get the t squared on its own, it makes sense to multiply both sides by negative 1. So that will bring the negative over here. Now, a lot of people will look at that and go, oh no, I've made a mistake. When you square t, and t has to be positive because it's time, you're going to have to get a positive number, and I've got a negative number. Is that the case though? No, because the natural log of half is a negative number. So we've got a negative number here. So it's going to work out as a positive number. So we're good. Now, 2 ways you could solve this. One is to do as I've just done, and then at this point say, all right, to get t, we need to take the square root of this. And don't worry that it looks like a negative number, it's actually not. So once we put that in there, take the square root of this, we're going to have this here. Now that looks awkward, doesn't it? It looks yucky. We've been asked for it as an exact value. So really it would be nice if we could tidy that up a little bit. Now there's ways to tidy it up. We can get rid of the negative by using the power law and taking that negative up here as an index and thinking, what is half to the power of -1? It's actually 2, isn't it? Because it's 1 over a half. So this is exactly the same as square root of the natural log of 2. And that is a much neater answer. Now, another way that you could go if you were getting a bit stuck here and you were worried that you had a negative number and your square couldn't equal a negative, back at this step here, you could rewrite this term without the negative index. You could have gone from here and said a half is equal to 1 over e to the power of t squared. And now you can see that take the reciprocal of both sides here, and we've just got 2 is equal to e to the power of t squared. So now when you take the log, you say e to the power of t squared is equal to 2. So then taking the square root of each side, it comes out much more neatly. So either way is okay for finishing off there. And then of course we need to refer back to get our units. Time is in seconds, so we need to add that. And that will be the time that it is stationary. Now for part B, you really do need your formula for velocity from part A. Part B says show that as time increases, the object approaches a limiting velocity and state what that limiting velocity is. So we had our formula for velocity already from part A. We found that v was equal to 2e to the minus t squared minus 1. So now we need to reason that as t approaches infinity, what's going to happen to v? Well, let's think about what it's going to approach. Now, if we sub infinity in here for t, we've got 2e to the minus infinity squared minus 1. Now, rewriting this so that it's easier to reason what it means, let's get rid of the negative index and say that this is 2 over e to the power of infinity squared minus 1. All right, think about this number. E to the power of infinity squared, that is ridiculously big. So 2 over an infinitely large number is as good as nothing. It's approaching 0, isn't it? So this is approaching 0 minus 1, which is just minus 1. So therefore we can say velocity approaches -1. Now, can velocity be negative? Yep, it just means that it's going in a negative direction. -1 meters per second.